Hello everyone, I'm Frank. Welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Something Stupid by Sudoku, and here are the rules. Read the rules or don't. I won't blame you if you skip them. Smiley face. Okay. We will read them anyways. Here are the rules. We have normal Sudoku rules apply. That is, each row, column, and 3x3 region has to contain the digits from 1 to 9 once each. We have Renban lines, where the pink Ren line must contain a set of consecutive, non-repeating digits in any order. So, for example, this could be the digits 1 through 7, 2 through 8, or 3 through 9. They could not be something like 1, 2, 4, 5, 6, 7, 9, because that does not form a set of consecutive, non-repeating digits. We have German whisper lines where adjacent digits on the green line must have a difference of at least 5. So, for example, if this were a 3, this would have to be an 8 or a 9, because those are the only digits which are 5 or more away from 3. And that's an example of how German whisper lines work. We have region sum lines, where box borders divide the blue line RSL into segments with the same sum. So this is a segment which must sum to the same sum as this segment, which must sum up to the same sum as this segment. So remember, these three add up to the same sum as this segment does, which adds up to the same sum as this segment does. And that's how region sum lines work. We also have palindrome, where the digits on the gray line, pal, form a palindrome. So that means they read the same forward and backwards. So it reads the same going this way as it does going that way. And that's how a palindrome works. We have index lines, where the turquoise line, I and D, is an index line. And that is the digit in the nth cell along the line, starting from the diamond, indicates the position along the line where the digit N appears. So, for example, this digit here, say this was a 6. That would say that the digit this is in the first cell, so this is N is equal to 1 here. That means the position along the line where the digit appears, 6, has to have a 1. Therefore, this is 1. And lines cannot index past the last digit of the index, or the last part of the index line. So, for example, this could not be 9 because there is no 9th position on this index line. So that's an example of how index lines work. We have arrows, where digits on the arrow sum to the digit in the circle from which the arrow emerges. So this could be, say, like 1, 2, 1, 1, and this could be 5, because the sum of all these digits is 5. 1 and 2 add up to 3, plus 1 add up to 5. So this is an example of how arrows work. And we have double arrows, where the digits on the line between two circles must sum to the same total as the digits in the two circles. So these 5 digits must sum to the same sum as these 2 digits here. So think of this sort of as like a region sum line, but the segments are essentially both circles and the digits that are in between those circles. So that's how double arrows work. We have killer cage, where the digits of the cage in the cage must sum to 7. That's pretty straightforward. And this is an odd digit, where a cell with a gray cell must contain an odd digit. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. Where do we start? This is the same digit as this, and they must be equal to the same sum as these three. So this has to be 1 through 6, adding 2 up to at most 9, but at minimum 6. So this would be 6 through 9, this is 6 through 9. These are the same digit. And they must add up to these. So this digit cannot be here or here because they are the same digit. They can't be on the line. This digit, if it were 6 through 9, could not add up with any other digits here to add up to another digit. So if it's 6 at minimum, then that's plus 1 and 2, plus 1, which adds up to 10, which is not a digit. So this cannot be pink, therefore this must be the pink here. So the pink in this row 1 cannot be any of these cells because of the pink digit in the box. It has to be 1, oh. And what is this digit? On this Renban, what are the possibilities? I listed them out basically in the beginning, so, but they are the digits 1 through 7, 2 through 8, or 3 through 9. Well, that means all of these digits have to contain 3 through 7, right? 1 through 7 contains 3 through 7, 2 through 8 contains 3 through 7, and 3 through 9 contains 3 through 7. So this cannot be 3 through 7. It's 8 or 9. This digit then, if this is 1 through 7, this would be the other 8 or 9. If it's 2 through 8, this would have to be 1. And if this cannot be 3 through 9. Because that would eliminate all possibilities for that cell. Okay, so in this box, left central box, the pink digit cannot be here or here. It can't be here because of the palindrome line, so it must be one of these 3 digits here on this German whisper line, but we don't know which. We know this is a 1, 2, 4 triplet. Okay, so that I probably should have started here actually, but anyways, I went down this pink path. This was fine too to start with. This has to be a 1, 2, 4 triplet because that's the only 3 unique digits which ever add up to 7, right? 1, 2, 3 adds up to 6. 1, 3, 4 adds up to 8. So 1, 2, 4 is the exact set. On a German whisper line, or as I like to call them, whisper 5 lines, you'll always have a low digit next to a high digit, which has to be next to a low digit. So, and the reason why you know that is the digits 1 through 4, what digits can be next to it? And these are considered low digits. 1 can be next to 6 through 9, 2 can be next to 7, 8, or 9, 3 can be next to 8 or 9, and 4 can only be next to 9. So next to a 1 through 4, you'll always have a digit from 6 through 9. And it works vice versa. What digits can be next to a high digit, which is 6 through 9? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1, 2, or 3, and 9 can be next to 1 through 4, which are all low digits. So you'll always alternate between low and high digits on a whisper 5 line. Well, that means whatever digit is here, you'll have the opposite set here, which means that you'll have the same set as it here. Well, we know all 3 of these are low. If this was low, this would have to be high, and that would have to be low, which is not possible because we only have 4 low digits possible, and we have 3 of them here. So this must be a low here, which makes this a high here, and 8 and 9 is a high, so therefore this must be the pink 8 or 9. This is low. This is high. That means the remaining digits in column 1 have to be non-low. So these are 5 through 9 here. This must be low, this must be high, and this must be low. Well, that means these digits are, first of all, 5 is not going to be on the German whisper line because 5 can never be on one of them. 5, if you subtract 5 from 5, If you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. And we have 4 low digits accounted for in this box, so that means the remaining digits must be 5 through 9. But it cannot actually be 9 because one of these low digits has to be 4. And again, 4 has to be next to a 9. So 4 has to be one of these two digits next to only one unique digit on a Whisper 5 line. Because again, 4 can only be next to 9. That means 9 has to be one of these two digits here. So 9 cannot be here. This actually has to be a 5-6 pair because all the high digits in this box on the Whisper 5 line are next to two unique digits on the Whisper 5 line. And again, 6 can only be next to one unique digit on a Whisper 5 line. So this is a 5-6 pair, which forces this to be a 5-6 pair to be a palindrome. Okay. That means where's the pink? The pink has to be one of these 3 digits, 3 cells here. It has to be one of these 3. The digits on the index line have to be 1 through 6. Okay. All of these digits see this cell, either by in the same column, or the same row, or the same box. So where is this digit on the index line? It has to appear here. Because you can't have 2 cells pointing to the same digit. You can't have, basically the index line has to form a complete set of the digits from 1 to n, whatever the length n is. So this is 1 to 6. Because every digit has to be pointed at somewhere, right? So this has to be a 5 or 6, and it matches this digit here. So this 5, 6 eliminates 5 and 6 in the rest of the box as a possibility. So this has to be 1, 3, 4 adding up to 8, or 2, 3, 4 adding up to 9. So this is guaranteed as a 3 or 4 here. Let's see. This digit is at least a 5 through 9, right? Because, again, we had a minimum of 1, 2 with 1 and 1. So this is 5 through 9. That means we have, these are all high digits in row 4. So that means they're digits from 6 through 9. That's 3 of them. This is 5 or 6, and this is 5 through 9. That means the rest of the row cannot be the digits 5 through 9 because we have 5 cells which require the digits 5 through 9. So this can't be 5 through 9. This is a low, and this must be low here. So this is 1 through 4. These are all lows. This cannot be, this could be, so can this ever be 5 or higher? The answer to that is no. Or sorry, we're looking at 6 or higher here. The answer to that is no. And this can't be 5 or 6 because of the 5, 6 pair in the box. It can't be 3 or 4 because these must add up to 8 or 9, which means it's 1, 3, 4, 2, 3, 4. So this is guaranteed to be 1 or 2. Which means in this box, we know the remaining digits have to be 7, 8, or 9. So this is 7, 8, 9, this is 7, 8, or 9, and obviously this is 8, 9. Here, you don't have too much. This is low. Okay, we do have that. So that means We have a 1 through 6 sextuplet in column 6, which eliminates 1 through 6 in the rest of the column, so this must be 7, 8, or 9. And where's the other 5 or 6 here? It has to be here. So that means along this index line, we already know where the 5 and the 6 have to be. Also, this cannot be 5 because that would say 6 has to be in the 5th position, which would be 1, 2, 3, 4, 5, which is not possible. So this has to be 6, which makes this 5, which makes that 6, which makes that 6 to be a palindrome, which makes that 5. This 6 eliminates 6's possibilities here. Whereas the 5 in column 6, it must be one of these two cells, and it cannot be here, so it has to be here. Which means 3 has to be in the 5th spot, so this is 3. That means this can't be 3, and these can't be 3 or 5. This can't be 3, and this can't be 3. We have a 1, 2, 4 triplet in column 6, which eliminates 1, 2, and 4 in the rest of the column. This can't be 1, 2, or 4, it's 3, which eliminates 3 in the rest of the box. We have a 1, 2, 4 triplet in column 5, which eliminates 1, 2, 4 in the rest of the column. That leaves the remaining digits as 3, 5, 7, 8, 9. And 5 cannot be here, whereas the 5 in column 5, it has to be here. So 3 has to be one of these two cells. This 6 eliminates 6 here. Oh, these are all high digits. So that forces this. Since these are all high, this cannot be a high digit. We have 4 highs in that row. So this must be 5. So this is 5, which forces this to be 1, 1, and this is a 1, 2 pair. That leaves this not as 1. This is a 2, 4 pair here. This 1 eliminates 1 here. So this is a 2, 4 pair here. Therefore, this is 2, 3, and 4, adding up to 9. So all the pinks are 9. So this must be 9. The 4 can only be next to a 9, so this cannot be 4 here because this can't be 9 anymore. So this is 4 here. 9 cannot be here. This can't be 9. This is 1 or 8. We don't know which. This has to be a high, so it's 7, 8 as a pair here. 4 can obviously not be here, so that leaves this as a 2. So this is 2, which makes that 4. We have a 1, 3 pair here, because those are the only low digits remaining. And this 1, 2, 4 triplet eliminates 1, 2, 4 in the rest of the column. So this can't be 1. This is 3, which makes this 1. 3 can only be next to 8 and 9 on a whisper 5 line, so this is 8, which makes that 7. 3 eliminates 3 here. And this can't be 9. So this is 7, 8 as a pair. This is 7, 8 as a pair. What is the remaining digit in column 5? It's 3 here. This 4 eliminates 4 here, so it's 2. That's saying that 4 has to be in the second spot, so this is 4. This 4 eliminates 4 here, so it's 2 and 4. This 2 and 4 eliminate 2 and 4 here, so it's 1. Okay. That means this cannot be 8. It's a 5, 6, 7 triplet. Okay. Remaining digits in the central box are 1, 7, and 8. This can't be 1 because of the 1 in the row, so this is a 7, 8 pair, which eliminates 7 and 8 in the rest of the box, so this is 1. That leaves the remaining digits in row 5 as 4, 6, and 9. Remaining digits in row 6 are 2, 7, 8. 2 can never be here because if this is 2, this would be at maximum 9, and 2 and 9 add up to 11. But these 5 digits add up to a minimum of 1, 2, 3, 4, 5, which adds up to 15 at minimum. So this can't be 2. This is 7 or 8 with 7, 8, or 9. This is an odd digit, and it cannot be 1 or 5. So it's 3, 7, or 9 here. This 4 eliminates 4 here. This 1 eliminates 1 here. Where is the 2 on this Renban? Which it has to be. It can't be here, can't be here, can't be here, so it must be here. So this is a 2, which means this can't be 2, that's 1, which makes that 2. 1 eliminates 1 here, so this is 8, which means on this Renban, it has to be 1, 3, and 4 remaining, so it's 1 through 7. 4 cannot be either of these, so this is 4. This can't be 1 because of the 1 in the row, so this must be 1, which makes this a 3. Okay. 1 cannot be here, or here, or here. This is at most 9 and 8, which adds up to 17. 17 requires a 1 to be in the sum. So 1 cannot be here, cannot be here, can't be in the middle row. So where is it? It has to be on the line, because the minimum without 1 would be 2, 3, 4, 5, 6, which adds up to 20, which is much bigger than what 17, which is the max this sum can add up to, can be. So this is 1, which eliminates 1 here, so this must be 1 here. This 2 eliminates 2 here. Where's the 2? In row 6. It must be here. So this is 2 here. Where's 2 then in column 9? It has to be one of these 2 digits. Can you ever add up to 17, which is what 8 and 9 max can add up to, without a 3? I think the answer to that is no. Right? 1, 2, 3, 4, 7, and 1, 2, 3, 5, 6. So 3 cannot be here. 3 also cannot be here. 3 has to be on the line, so it's one of those 3 there. Okay. We have a 2, 3, 7, not 7, 6 triplet in column 4. In column 2, it's what? 6, 7, 9. In column 3, we have 3, 5, and 8. 5 cannot be here because of the 5 in the row. This digit cannot be 1, 2, or 3. It's either 4, 6, 7. And those are the only possibilities. It cannot be 8 because 1, 2, 3, 4, 8 adds up to 18, and this can only add up to 17 here. So we have 4, 6, or 7 here. On the line again, it can only be 2 through 7. This can't be 2 or 5. This can't be 4. Okay. Remaining digits of row 2 are 5, 6, 7. Remaining this 5 eliminates 5. This 5 and 6 eliminates 5 and 6 here, so this is 7, which means this can't be 7 here. This is a 5, 6 pair. So 7 has to be one of these 2 digits here. That means 7 is one of these 2 digits here, one of these 2 digits here. That means we have 2 7s already accounted for in columns 8 and 9. The rest of columns 8 and 9 cannot contain a 7. So this cannot be 7 here and cannot be 7 here. So this is 9. So therefore, this can't be 9 It could be a 7-8 pair adding up to 16 or 15, or an 8-8 pair adding up to 16. Either way, this cannot be 7 here. This is either 2, 3, 4, 5, 1, 2, 3, 4, 5 adding up to 15. Or it's 2, 3, 4, 1, 2, 3, 4, 6 adding up to 16. So this is 9, which means this cannot be 9. This cannot be 9. None of these are 9. Okay. So we're guaranteed that the 4 has to be on this line. This can't be 7, so 7 has to be one of these two digits here. We have, again, no 2, 3, 4. It could be 5, 6, 7, or 8. And 5 cannot be here because of the 5 in the column. 7 can't be here because of the 7 possibilities. This has to be 7 and this has to be 7. Run band's done, arrow's done. German whisper's done. Palindrome's done. Cage is done. Index line is done. This 7 eliminates 7 here, so this is 8, which makes this 7. 8 eliminates 8 here, so it's 7, which makes that 8. Remaining digits in row 3 have to be 3 and 4. This 3 eliminates 3 here, so it's 4, which makes that 3. 4 eliminates 4 here, so it's 6. So this must be 2, 3, and 4 here. This 6 eliminates 6 here, so this is 8. This can't be 6 or 8. It's a 5, 7 pair. That means this must be 8 and 8 to add up to 16. This can't be 2 again. This 4 eliminates 4 here. This 8 eliminates 8 here, so it's 3. So none of these could be, this can't be 3 or 8. It's 5. This can't be 3 or 5. It's 8. 5 eliminates 5 here, so it's 7 and 5. This can't be 3 or 6, so it's 2, which makes this not 2, so it's 4, which makes this 2. This 6 eliminates 6 here, so it's 7. So none of these could be 7. This can't be 7 or 8, so it must be 9. This can't be 8 or 9, so it's 7. 4 and 6 here eliminate 4 and 6 here, so that's 9. That leaves this digit as an 8. This 8 eliminates 8 here, so it's 7. This 9 eliminates 9 here, so it's 6, which makes that 9. This can't be 2 or 6, so it's 3, which makes this 6. This 3 eliminates 3 here, so it's 2. This 3 eliminates 3 here, and it can't be 2 or 3, so it's 4, which makes that 3. 4 eliminates 4 here, so it's 6. This can't be 6 or 9, so it's 4. This 7 eliminates 7 here, and it can't be 5, so that's 6, which makes this 5, which makes that 7. 5 eliminates 5 here, so it's 6. This makes this a 9, and this a 5. And that's the solution. Yep, fairly straightforward. Seems fine. Not completely stupid, I would say. I mean, it's just basically, you know, something thrown together, I think. And it seems pretty cool. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.